So this here is a look at our modified sketch. It's the same sketch as before, but we've just added a couple of lines to it. Again, we're using the servo library here. Okay, we still have our front servo and back servos attached just as before. We still have our forward list, that is our position list. That kind of defines the way the object moves. But in this case, we've added a list backwards to define the backwards walking pattern. Adding that extra line there gives us a degree of freedom in kind of just adjusting how the walker moves backwards if we care to do so. I won't do that here. I'll leave that for the viewer as an exercise. And then we also define a number light pin. Okay, that's going to be the pin, the analog input pin that the photosensor is connected to. Okay, so all we're defining is light pin to be a value of 0 at this point. Moving down, our setup is the same. We're still attaching the front servo to pin 9, the back servo to pin 10. Now we focus on our loop. It's basically the same as before, but we've added an if and an else command. Okay, so if the voltage read, okay, analog read is the voltage at analog pin, light pin, which we've defined to be 0 already. So this is basically the reading of the voltage at pin 0 of the analog inputs, is greater than some 800 internal units, okay, then the animal will follow the backward pattern. Okay, otherwise for values less than 800, it's going to follow the forward pattern. You'll note that the forward and backward patterns are very similar to each other. To make it go backwards, the front servo takes on the odd valued positions, that's here, +1, while the back servo takes on the even valued positions, and that's here, so +0, 2 n values. The delay is set to be the same as before. The opposite is true for its forward motion. The front servo will take on the even valued positions, while the back servo will take on the odd valued positions. Okay, so that's what gives it its sort of opposed motion, forward and backward. We're just swapping the even and odd positions. It's kind of like taking the thing and putting it, say 180 degrees out of phase or something like that. When your code starts getting complex like this, where you have if statements within do loops and stuff, it's really important to keep track of the brackets. One of the easy ways to check for, to make sure you have adequate bracketing is to double click next to a bracket. Okay, so that'll highlight all of the text that falls to within those brackets bounds. Alternatively, you can actually kind of just place the cursor here to the right of the bracket, and the one that's lit up over here, you see that? That's its partner. Okay, so if we move up one bracket, we'll see that we've actually entered now the do loop, or the for part of the loop. Okay, we can actually see if we can capture the else statement. So there's that. Okay, so this is kind of like a sanity check, just to make sure that you have the thing written properly. If you don't, it probably won't compile anyway. Finally, this code can be found in the course compass.